Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with the time series modeling, and that too the structure of volatility modeling. In the last lecture we have discussed this concept. Technically, time series models in one way we can classify into two different parts, the linear structure and the nonlinear structure. We have discussed couple of problems under the linear structure, starting with order regressive scheme, moving average schemes, ARMA schemes, ARDL schemes, which we have discussed slightly in the last lecture and some of the previous lectures. And again in the last lecture we have also covered the nonlinear structure, and that too we have highlighted couple of models, just taking the clue or extension from the linearity structure, that too the structure of autoregressive scheme, moving average schemes and ARMA schemes. In specific we have discussed three aspects of nonlinear modeling, that to nonlinear time series modeling. The first one is the arch clusters, the second one is the gauge cluster, and the third one is the artificial neural network. However, we will give more trace on arch cluster and gauge cluster, because these techniques are too important so far as volatility modeling is concerned. Though artificial neural network is a kind of nonlinear clusters, but basically it is a classification technique and we have lots of limitations compared to arch modeling and gauge modeling. That means technically artificial neural network is not a solid technique to represent the volatility concept, which is very essential or very important in some of the engineering and management problems. So, that is why the plan of the lecture is just to start with the artificial neural network concept and then move into arch modeling and gauge modeling. Before that, I like to give you little bit stress on nonlinear structure. Of course, we have discussed lots of nonlinear modeling, not specifically in the context of time series modeling. We have discussed simple model with nonlinear functional form, and we have also discussed some of the qualitative response regression modeling, that to dummy modeling, where we have also discussed various types of nonlinear models, that to nonlinear regression models, specifically logit model and probit model, which is very useful, very essential for most of the engineering problems, where dependent variable is the kind of qualitative in nature, and then we use both probability density functions that brings the logit model and then normal density functions that brings the probit model. And in that context we have not used specifically the time series structure. That model may be used in the time series data, but more accurate, more appropriate in the case of cross sectional data or cross sectional setup. But what we like to discuss here today is the nonlinear types of econometrics model, where we like to use two things or we like to connect two things, that is very important here. The first one is the time series data and the second one is the involvement of lag variables, which is actually feasible when there is a time series data. So, as a result we may be in a position to address the volatility aspect and that to the arch modeling, Gauss modeling and the kind of ANN, artificial neural network. Of course, artificial neural network can be used in the cross sectional setup, but it can be also equally useful in the time series data. But artificial neural network is not such a big tool to highlight the volatility aspects. So, in any way we like to touch upon three things: the ANN, artificial neural network modeling, the arch modeling, that is autoregressive conditional heteroscedasticity, and the Gauss modeling, that is generalized autoregressive conditional heteroscedasticity modeling. But we will give more emphasis on arch modeling and Gauss modeling compared to artificial neural network. We just give little bit touch upon the ANN, then we will move to artificial arch modeling and the Gauss modeling. So, let us start with what is exactly the nonlinear concept, and then we will come into the kind of arch modeling, Gauss modeling and neural network modeling. Of course, in the arch modeling and Gauss modeling, one common is that we need to have a first error component, and then error component can be used as an instrument to highlight the or to address the arch modeling and the Gauss modeling, which is not exactly in the case of neural network. That is the difference, big difference between the arch and Gauss cluster and then the artificial neural network cluster. So, let us start with this simple understanding about the nonlinearity, and then we will move into these three models and we address volatility aspects, that to solve some of the engineering problems where we need actually predictions, and that too with the help of volatility structure. Volatility literally means variations, when the variation is a very uneven nature, that is what the term volatility literally means, and it affects drastically or it affects lot in the prediction process and forecasting process. That is how we like to know how we can deal, so that we can minimize such forecasting error or prediction error, and then we can do the better in the decision making process, and that too some of the engineering problems. So, let us see here how is this particular structure. That is what we have already discussed. There are many types of nonlinear models, of course, we have discussed, and in this case typically we are touch upon ANN, arch and Gauss cluster, and besides ANN and arch Gauss clusters we have switching models, bilinear models. We have plenty of models, but with time constraints we like to just touch upon artificial neural network, and then we will cover arch and Gauss cluster. But besides this cluster there are various other models like switching models and bilinear models, which is actually somehow connected with the arch cluster and Gauss cluster. So, let us start with some kind of nonlinearity, and here the nonlinearity starts with actually the kind of variables, not exactly the functional form, and earlier we have used a concept called as Ramsey's reset test, that is called as a regression specific, reset stands for regression specification test. So, the process of this test is that even a particular model is passed through specification test, GFT, goodness of fit test, and that to diagnostic test, till that model cannot be completely declared as the reliable model for the prediction and forecasting. So, as per the Ramsey structure, so the end part of this reliability may be using the reset test. The test basically deals with error component, and then we means this first step of this process to estimate the model and have the error term, and then go through all the specification test, GFT test and diagnostic test, and after that again rerun the model by applying reset test, where error component as a function of the estimated variables, that is the predicted variable, which we generally recognize as y cap, and that too with a lots of in a nonlinear setup. For instance, here we have ut, and then we connect with this y cap is the estimated y, and we connect with the y hat squares, then the y hat to the power q and so on, that to y hat to the power p. So, degree of linearity starts here. So, that means this same estimated variables use as the independent variables to predict the error terms, and then check the reliability of the model. So, that means somehow this kind of nonlinearity we have already discussed. Here the dependent variable is the residual series, and the independent variable are the squares cubes of the fitted values, and then test the model whether it is reliable or not. Same we have just estimate the model and have the R square, and that R square need to be tested whether it is actually reliable or not. That is what the basic structure of Ramsey's test. So, that means technically we have already used this concept of nonlinearity. Besides, that means besides Ramsey's reset test, we have couple of nonlinear tests like BDS tests and the bispectrum test. Starting with BDS, it is a pure hypothesis test, that is it has its null hypothesis that the data are pure noise, that means completely random. It has been argued that to have power to detect the variety of departures from the randomness, the linear or nonlinear stochastic process, deterministic choice, etc. In fact, the BDS test follows a standard normal distribution, that too under the null hypothesis. This test specifically, that is the BDS, can be used as a model diagnostics on the residuals to see what else left. If the proposed model is adequate, then the standardized residual should be white noise. That is what the reliability, and that is what the structure of the requirement. Now, just I am just touching upon couple of nonlinearity structure, and that too in a time series setup. So, starting with reset, BDS, bispectrum test, and then touch upon the slightly neural networks, then we will move to the arch cluster and Gauss clusters, which is actually the true story of this volatility modeling. In brief, artificial neural network are a class of models whose structure is broadly motivated by the way that the brain performs some kind of computations. Neural networks have been widely used in engineering and management for tackling time series and classification problems. Of course, it is a more excellent technique in classification compared to time series, but sometimes we use in time series data and time series modeling to check the forecasting accuracy compared to other nonlinear models as well as the linear models. That means, technically the particular engineering problem may be common, but we can estimate, we can analyze, we can use the model for decision making process in the form of linearity structure and nonlinearity structure. When we are comparing the particular problems and the two different aspects, linear versus nonlinear, and by default neural network can be used as a tool. More specifically, that too, so far as applications are concerned, we use NNN to forecast some of the engineering outputs or managerial outputs. More specifically, neural networks have virtually no significant theoretical motivation, that too in engineering. The general perception is that it is a kind of black box. How it happens, it's nobody knows. However, theoretically it gives some kind of clue how it predicts and do the kind of forecasting. It has some kind of mathematical understanding, mathematical logic and mathematical structure to predict the kind of requirement. Even though the inside box is not clear, which is called as black box, still that technique is not so relevant. It has lots of utility and importance to predict certain things and compare the results in a nonlinear angles compared to linear angles, even nonlinear angle with different models. They can fit any functional relationship in the data to any arbitrary degree of accuracy. So, that is what the basic structure of neural network, and the some of the other features are it has actually couple of modalities, and most of the occasions we use feed forward network models. These have a set of inputs linked to one more outputs through some hidden or intermediate layers. So, that means actually it is the classic example of interdependence. Some independent variables may not affect the dependent variable directly. It can be passed through some other variable. That is what called as indirect relationship or intermediate, or which we represent here in the neural network is called as hidden layer. The technique is such a big or some kind of very important in the sense, even if we do not know the indirect relationship, the kind of interdependency, that hidden layers will explore and find out some way. Even though theoretically there is no clue, but still this model can bring some kind of reality to predict such dependent variables. Of course, the size and the number of hidden layers can be modified to give a closure or less close fit to the data samples. A feed forward network with no hidden layers is simply a standard linear regression model. So, that means technically it has a close connection with linear models. So, if you remove that hidden layers which actually brings the nonlinearity structure to predict the dependent variable. So, since there is some commonality, so simple regression results can be compared with artificial neural networks results, and then check the validity and the requirement as per the particular engineering requirement and the decision making process. Neural network models specifically this work where engineering theory has virtually nothing to say about the likely functional form between the relationship among the variables. Okay. So, that means we may not have actually solid theory how is the basic functional form. So, neural network can bring some kind of clustering. That is what the beauty of this particular technique to address some of the engineering problems. Of course, we will not go in details, but this is a some kind of structured technique through which you can actually predict certain engineering problems. Neural network has some advantages and some disadvantages. We have highlighted the particular plus sides, where if we do not know or if we have no idea theoretically how to bring a functional form, then blindly we can use neural network, as it is actually kind of black box mechanisms which helps lot to predict the environment. However, neural networks are not so popular in engineering and have lots of limitations. The coefficient estimates from neural network do not have any real theoretical interpretation. That is the big disadvantage compared to linear structure and the type of model like arch modeling and gauge modeling. Virtually no diagnostic or specification tests are available for estimated models. Simply neural networks can provide excellent fits in sample to a given set of training data and then give excellent out of sample prediction accuracy. That is the beauty of this particular technique. This usually brings from the tendency of neural networks to fit closely to a sample specific data features and the noise, and so they cannot generalize. That is the big deal. Moreover, nonlinear estimation of neural network models is computationally very time intensive, particularly for instance, if the model must be estimated repeatedly when rolling through a samples, that is the again big disadvantage. In any way, neural network has some kind of merits and some kind of demerits. Of course, all models has some kind of demerits, but still this model can be used as a tool for any kind of prediction and forecastings. However, we are not going in details because this type of models are very frequently used in data analytics and machine learnings. So, that is why we are not so interested to discuss in details about this technique, which is having actually less impact in the kind of the item which you address the volatility concept. So, so compared to neural network, the arch modeling and gauge modeling will be more appropriate and more accurate to do the predictions and do the forecasting as per the particular requirement. So, some models for volatility means we are specifically highlighting modeling and forecasting like stock market volatility, or some kind of engineering volatility, and that is subject to empirical theoretical investigations. There are number of motivations for this line of investigations, because what I have mentioned volatility is the key in specifically time series data, which may specifically dilute or drastically affect the prediction and forecasting, because you have no guarantee and some kind of stability to predict certain things. So, that means statistically or econometrics angles, larger the volatility which you theoretically predict through the standard deviations or variance of the variables, then lower is the reliability, lower is the accuracy, and lower is the efficiency of the model so far as a prediction and forecasting is concerned. So, what we usually do in normal case, we try to transfer or restructure the data and the kind of problem in such a way, so that the type of variation and the volatility may be reduced some extent at the first instance. If that is the case, then we may not necessarily require the ASK kind of modeling and GASK kind of modeling. But the fact is that some of the engineering problems and management problems are such a complex, where we may not actually predict properly. So, as a result, we need actually such kind of models, that is the ARCH model and GASH models. So, typically there are number of motivations for this lines of research and discussion. First one is the volatility is one of the most important concepts in engineering and management, because it brings uncertainty, and it is the kind of component which can brings the risk factors. Theoretically or literally, larger the risks, lower is the prediction accuracy. With high risks, you cannot predict the things very accurately, very effectively, and very efficiently. That is what, and that is what the deal, and that is what the need actually in the first instance. Since most of the things actually risk taking or attachment of risks. So, this kind of models are very user friendly to predict some of the engineering concept or engineering outputs. As we have already discussed, volatility as a measured by the standard deviations or variation of a variables. So, that is why it is not a big deal, or it is not a big issue. In fact, it is not at all a complex, just bring the volatility in variations, and then you predict this requirement. That is what the kind of requirement, and that is what the nature of this volatility modeling, that to ARCH cluster and GASH clusters, which we will discuss in details in the next lecture. In the meantime, we will stop here. Thank you very much. Have a nice day.